Right now, as you're watching this video, someone somewhere is collecting your Bitcoin's encryption keys. They can't crack them yet, but in 2030, they will. And when they do, $2 trillion worth of cryptocurrency could vanish overnight. This isn't a conspiracy theory. This is quantum physics, and it's real. I'm here to explain why the most powerful technology humanity has ever created might destroy the most revolutionary currency we've ever invented. And more importantly, what we can do about it. Here's what we're going to cover. First, I'll explain quantum computing the way Richard Feynman would. No complicated math, just the raw truth about how it works. Second, we'll dive into why Bitcoin's encryption, which seems unbreakable today, becomes trivial for quantum computers. And third, I'll show you what the crypto world is doing right now to prepare for this threat. By the end, you'll understand exactly what's at stake and why 2030 isn't some distant future. It's just around the corner. Let me start with something that should terrify every Bitcoin holder. In 2024, the Federal Reserve issued a warning that almost nobody paid attention to. They said quantum computers pose a serious threat to cryptocurrency security. But here's what's really scary. The attack has already started. It's called Harvest Now, Decrypt Later. And it works like this. Imagine you send an encrypted message today. A hacker intercepts it, but they can't read it. The encryption is too strong. So, they just save it. They store it on a hard drive and wait. They wait for quantum computers to become powerful enough. And when that happens, maybe in 5 years, maybe in 10, they crack it open like it was never encrypted at all. This isn't theoretical. Intelligence agencies are doing this right now with government communications. And they're absolutely doing it with cryptocurrency transactions. So how much Bitcoin is at risk? Let's do the math. There are approximately 4 million Bitcoin that have been lost or abandoned over the years. These coins are sitting in old wallets using outdated, vulnerable encryption. At today's prices, that's roughly $240 billion. But here's the thing. It's not just lost coins. Every single Bitcoin transaction you've ever made is recorded on the blockchain forever. And many of those transactions expose your public key, which is all a quantum computer needs to derive your private key. According to Alice and Bob's CEO, Teo Puranan, who works directly with NVIDIA on quantum computing, we could see cryptographically relevant quantum computers by 2030 or shortly after. That's 5 years away. All right, now I need to explain quantum computing. And I'm going to do it the way Richard Feynman would, with no BS, no complicated equations, just the truth about how nature works at the smallest scale. Your computer, the one you're watching this on, works with bits. A bit is either a 1 or a 0, on or off. That's it. When your computer tries to crack a password, it tries every combination, one at a time. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, and so on. If the password is long enough, this takes forever, literally longer than the age of the universe. But quantum computers don't work with bits. They work with quantum bits. Qubits. And here's where things get weird. A qubit isn't just a 1 or a 0, it's both at the same time. This is called superposition, and it's not magic. It's just how particles behave at the quantum scale. Richard Feynman used to explain quantum mechanics with arrows. Imagine every possible state as an arrow pointing in a different direction. A classical bit is just one arrow, either pointing up or down. But a qubit is all the arrows, all at once, spinning and interfering with each other. So when a quantum computer tries to crack a password, it doesn't try every combination one by one. It tries all of them simultaneously. Every single possible password exists in the quantum computer state until it measures the answer. Let me put this in perspective. Bitcoin uses something called ECDSA, Elliptic Curve Digital Signature Algorithm. To break a Bitcoin private key with a classical computer would take every computer on Earth working together for trillions of years. But a quantum computer with about 4,000 stable qubits running Shor's algorithm could do it in about 10 minutes. Now, the quantum computers we have today aren't there yet. Google's latest quantum chip, Willow, has about 105 qubits. But those qubits are noisy. They make mistakes. The question isn't if we'll get to 4,000 stable qubits. The question is when. And most experts say between 2030 and 2035. Okay, so why is Bitcoin specifically vulnerable? To understand that, we need to talk about how Bitcoin security works. Every Bitcoin wallet has two keys, a public key and a private key. Think of the public key as a safe deposit box. Everyone can see it. Anyone can put money in. The private key is the only key that can open it and take money out. Bitcoin uses something beautiful. It's mathematically easy to generate a public key from a private key, but essentially impossible to go backwards, to figure out the private key from the public key. This is based on a math problem called the elliptic curve discrete logarithm problem. With classical computers, this problem is so hard it might as well be impossible. But in 1994, a mathematician named Peter Shor discovered an algorithm that could solve this problem efficiently on a quantum computer. Shor's algorithm exploits quantum superposition and something called quantum entanglement to factor large numbers exponentially faster than any classical algorithm. Here's the kicker. Bitcoin's ECDSA signatures expose your public key every time you make a transaction. And with your public key and a quantum computer running Shor's algorithm, deriving your private key becomes trivial. Remember those 4 million lost Bitcoin I mentioned earlier? Many of them are in what's called pay-to-public key addresses, an old Bitcoin address format that literally has the public key right there in the blockchain. These coins are sitting ducks. The moment quantum computers are powerful enough, anyone can claim them. And when $240 billion worth of Bitcoin suddenly floods the market, what do you think happens to the price? Yeah, not good. Okay, enough doom and gloom. Because here's the good news. We're not helpless. In 2024, the U.S. National Institute of Standards and Technology, NIST, released the first set of post-quantum cryptography standards. These are encryption algorithms that even quantum computers can't crack efficiently. The main ones are Crystal's Kyber for encryption, Crystal's dilithium for digital signatures, and Sphinx Plus as a backup. These algorithms are based on completely different math problems, things like lattice-based cryptography, which quantum computers don't have an advantage at solving. So can Bitcoin adopt these? Absolutely. Bitcoin has upgraded before. Remember Taproot in 2021? Same process. The Bitcoin community is already discussing how to implement post-quantum signatures. The challenge isn't the technology, it's coordination. Bitcoin's strength is decentralization, but that means changes take time. and require broad consensus. Several proposals are on the table: quantum-resistant address formats, hybrid signatures that work with both classical and quantum computers, time-locked transitions to give people time to move their coins. What should you do as a Bitcoin holder right now? First, if you have Bitcoin in old P2PK addresses, move them to newer Taproot addresses. This doesn't make them quantum-proof, but it's better. Second, don't reuse addresses. Every time you spend Bitcoin, use a fresh address. This limits public key exposure. Third, stay informed. Follow Bitcoin improvement proposals, BIPS, related to quantum resistance. And fourth, diversify. Don't bet your entire future on one cryptographic assumption holding forever. Here's the thing people miss. This isn't just about Bitcoin. Quantum computing threatens all digital security, banking, government communications, military systems, literally everything encrypted on the internet today. Bitcoin is actually in a better position than most systems because it's transparent. We can see the threat coming. Traditional banking systems, they're closed, proprietary, and much harder to upgrade. And here's what Richard Feynman understood better than anyone. Nature doesn't care about our engineering. The universe follows the rules of quantum mechanics whether we like it or not. We can either adapt or get left behind. I actually think Bitcoin will survive this. Not because I'm a Bitcoin maximalist, but because the community has proven it can evolve. We've seen it upgrade, adapt, and overcome challenges before. The real question isn't whether Bitcoin can become quantum resistant. It's whether we'll do it in time. And on that front, we have about 5 years to figure it out. That's not a lot of time. But it's not zero either. So, will Bitcoin collapse in 2030? No. Not if we act now, but it will require coordination, technical innovation, and a community willing to make hard choices. The good news? The Bitcoin community has done this before. If you want to dive deeper into quantum computing, I'll link Feynman's lectures in the description. They're free and they're brilliant. And if you want to see how other cryptocurrencies are handling this threat, let me know in the comments. Should I cover Ethereum next? Cardano? Let me know. Hit that subscribe button if you want more videos breaking down complex science without the BS. And if you learned something today, share this video, because a lot of people have no idea this is coming. Thanks for watching. I'll see you in the next one.